welcome to Interactive Visualization with Bokeh. My name is Bryan Vandeven. I'm really happy to be here. I'm with Continuum Analytics. Just a quick word. We're one of the sponsors of PyData. We're very happy to be a PyData sponsor, bringing Python tools and deployment ease to data analytics and data science all over the place. So we operate in a lot of domains. We also generate a lot of different technologies, things like Numba, Blaze. There were talks on Blaze yesterday, as well as Conda and Anaconda, and of course Bokeh. And the talk today is about Bokeh. So what is Bokeh? So Bokeh is a library in Python. Really, actually, we'll see that it's two libraries in Python and JavaScript for interactive visualizations inside the browser. And there's a lot of things we're trying to do with Bokeh. It's got a fairly wide scope. We'll talk about a lot of the capabilities of Bokeh today. But some of the things it can do are to generate very novel graphics. So one of the questions we're sort of trying to answer is, people ask, where is ggplot for Python, right? And so we're trying to create something along the lines of ggplot for Python that can generate very interesting, grammar of graphics style visualizations from Python that are in the browser. We also want to be able to handle streaming and large data, right? So if we have maybe a dashboard that has stock ticker data or real-time data coming from some sensor, we want to be able to have plots that can be updated continuously from that data. We also want to be able to handle large data, whether that's through interactive downsampling or some other techniques that we'll talk about in a minute. That's definitely an important use case for us. Again, browsers are first class concern. We want to be able to target the browser. Certainly in 2014, I mean, certainly very important to have a ability to sort of generate web apps and generate data applications in the browser across platforms. So that's a first class concern for us, is being able to generate these plots in the browser. Matplotlib compatibility, we have some level of that at the moment as well. Certainly very important. A lot of us have Matplotlib code. I certainly have a lot of Matplotlib code laying around. So we want to be able to leverage all of the years, man-years of work that have gone into Matplotlib, and to be able to provide an easy path to use and generate Bokeh charts from Matplotlib code. Last but not least, no need to write JavaScript, right? So I don't like to write JavaScript. I have to write a lot of it for Bokeh, but I don't want you to have to write JavaScript. And so that's really the goal behind Bokeh, is to keep things very simple, keep them in Python, and we'll see that. So there's definitely some interest in this sort of thing. We just passed about 2,000 stars on GitHub, which I thought was pretty crazy. A lot of forks, hovering around 10,000 downloads a month, which I think is also pretty intense. I've never really been part of a growing open source project that sort of started with no users and now has quite a few users. It's been a really a learning journey for me, and so that's really awesome. So anyway, there's definitely a lot of people interested in this, and so we have a pretty active mailing list. We have a lot of questions on Stack Overflow now. It's actually getting difficult to keep up with. We'd love to get more people involved and helping out, and we'll talk about that later as well. So anyway, all the features that I talked about, maybe let's examine those in a little bit more detail. So interactive means obviously what you might think of with interactive plots: panning, dragging, and zooming, but selections. And the important thing about the selections is that with the Bokeh server, which is this optional server you can use with Bokeh, you can round trip things like selections to and from a running Python process. So you can imagine having a user make a selection with a lasso tool or a box selection tool on your plot that gets back to your Python process that can inform some further computation, right? Maybe you want to do a regression through the selected points, or some other kind of statistical measure through those points, and then you can update the plot based on that. So you can have this full sort of two-way communication possible. Things like resizing the plot entirely on the client side. So in the browser, you can drag and resize these plots. Hover and click tools that allow you to sort of add additional drill down type information, look into additional columns of data that aren't presented visually, but you can present in the hover tool as you hover over different glyphs on the plot, that sort of thing. And then widgets. So people also ask about, what's Python's answer to R shiny, and so we're trying to be that as well. So you can go to bokeh.pydata.org. There's a documentation site there. We have a gallery right now. It's full of static plots. Let me go ahead and bring that up. Safari, they changed their icon. So if we go here to bokeh.pydata.org, we can go to the gallery. So there's all kinds of plots here that we can take a look at, and we can drill down and see these and see the source code. We're going to be in the process of expanding this gallery to include some server examples. These are all right now static plots, by which I mean they have static data embedded in the document, but they still have lots of interactive tools. So anyway, we're going to be expanding our gallery pretty soon, but quick preview of that. Okay, great. So anyway, I talked about interactivity and widgets. Here's another example. Again, we want to be able to have R shiny-like dashboards in Python, so you can have the sliders and drop-downs, all kinds of widgets that inform further computations or update the state of the plot. We can see a couple of examples of that as well. Go here. too many windows open. Let's find the one that I want to show. Here we go. So here's an example of a nice data table widget. We have lots of drop downs. So again, we can sort of drill down inside of our data and actually have that running. Do a selection here. And we can see the selection is linked inside the chart. You know, we can do all kinds of multiple selections as well. We have a nice hover tool that hovers over the data here. So that's sort of one example. Another one here. Cross-filter kind of example. Dashboarding, we'll come back to this later, but this allows you to sort of drill down into your data as well. You know, maybe you want to select by miles per gallon, have the chart update. Maybe you want to do some faceting. This is a pretty early tool. We're going to be working on fleshing this one out quite a bit. Another example with widgets here. Again, sort of a little stock correlation tool. We can do a selection here on the chart and see that there are linked selections there on the bottom, as well as selections here that are linked. So if we do this selection on the chart here, you know, we can see how the other charts update. So it's very easy to have this kind of linked brushing, linked panning, and linked behavior in Python that's typically expressed by sharing something. So we'll talk about the object model for Bokeh a little bit later, but typically in Bokeh, if you want to have linked panning, for instance, you share a range between two plots, or if you want to have linked selections, you'll share a data source between those two plots. And so it's very easy to spell and sort of explain these concepts and how to link charts in Bokeh. Other examples here. Here's that little function creator. So again, just sort of our shiny-like capability, the ability to have these nice feedback between Python. And we're working to have more of this available in pure standalone documents that you can simply transport. Right now, a lot of this will have to use the Bokeh server. Again, the Bokeh server is always optional, but it does afford extra features like these dashboards and widgets and whatnot. Go back to Adobe Reader. So there was that linked tables example as well. I also mentioned things like novel graphics. So that's, again, we want to be able to let people have the capability to write very interesting visualizations, right? So just a couple of examples of here. The first one up on the upper left is actually a Seaborn chart. So I mentioned that matplotlib compatibility. That actually also gets us things like ggplot.py and Seaborn compatibility as well right out of the box. So that's actually a Seaborn plot. And there's simply one line of extra code at the bottom that says, dot to Bokeh, and now all of a sudden you have a Bokeh chart with all of the interactive tools, panning and zooming that you would have on a Bokeh chart, but from your Seaborn code. Interactive sort of interesting visualizations. You have the two here in the middle, which are actual sort of scatter plots of rectangles, but you can generate sort of the periodic table from that, or this calendar that has these nice drill down hover tools available over those as well. There's the Les Mis co-occurrence chart. That's a reproduction of a Mike Bostock chart. He did co-occurrences of all the characters in Les Mis, and you can do a scatter and see what how many occurrences there were. The little vector field quiver plot there at the bottom. You can do some kinds of mapping things. Now we're still working on adding additional GIS and sort of projections and mapping capabilities, but right now you can still do fairly sophisticated maps already. And then finally, that upper right is kind of an interesting plot. I just wanted to reproduce this to show off capability. I saw that someone had done this in D3, and I said, I want to make sure I can do it in Bokeh. This is actually a chart from a guy named Burton. I think he's about 50 years old, showing the efficacy of different antibiotics, against different kinds of infections. And so, it's interesting what happened in this chart. I've never seen this before. It has an inverted radial axis. So obviously, the better an antibiotic it is, the smaller the minimum inhibitory dose will be. And so he wanted to highlight the antibiotics that had that smaller dose, and so there's actually an inverted radial axis. I'm not sure I would have done that in a real chart, but I thought it was kind of interesting and certainly something that we can reproduce here in Bokeh. So let me close a few tabs, show off a few more examples. Yeah, here's that Burton chart, right? So you can see that here, and again, all of those things are available. We can resize the plot here. All this stuff, of course, works in the notebook as well, right? So all of this is available in the IPython notebook. Here's that calendar chart. If I go to the gallery, here's that, again, Les Mis chart. We can sort of see the nice hover tool operates on that. We can go back to our periodic table. See a better example maybe with the hover. So here there's a lot of data. We have a column data source that has a lot of different data. Not all of it's visually displayed, but we can have this hover tool that can drill down into those additional columns of data and display them as we hover over the different glyphs. So sort of, again, nice for sort of exploration and drill down as well. Okay. Streaming and dynamic data is certainly something else that we want to be able to handle, right? I mentioned the case of maybe you have stock ticker data, maybe you have sensor data, whatever. We want to be able to handle that. And so typically that's handled with the Bokeh server. Again, the way Bokeh is architected, and we'll talk about that towards the end, is that if you push data to the server, the plot automatically reacts and updates. So it's very easy to have streaming data. You can just push data onto the Bokeh server, and that will work. So we can see a few examples of that as well. If I go over here to the spectrogram demo. So this is actually sort of a hybrid example. This one doesn't use the Bokeh server. The heavy lifting of creating all the plots is just a little bit of Python code that creates these plots, and then there's a small bit of JavaScript that actually does an AJAX call to a REST API to get the audio data, the FFT that's being done in Python, and then it presents that, and we have this nice updating plot, and we have this silly little radial graphic equalizer there at the bottom as well, just to sort of show that working. So we can sort of see an example of, let's see that, if I get a little tone generator here. Yeah. So yeah, we can see, sure enough, there's our nice spike going up and down. So I was embarrassed in another PyData by Peter Wang, who asked me to whistle, and I can't actually whistle, which is embarrassing. But so now I bring my faithful tone generator to show that off. But anyway, so that's a nice example, again, of streaming data. We want to make that a first-class concern as well. So there's a lot of different ways. You can use the Bokeh server, but you can also get a handle to your plot in JavaScript. And if you have JavaScript code that's already making AJAX calls to REST APIs or getting data through JavaScript, it's possible to update using JavaScript as well. So we want to make it very flexible to have lots of different ways to embed. Another example here. Let's see if I have it open. I may not, actually. Let's see. So here's an example that uses the Bokeh server. So this is another, at the bottom we have a little bit of code that generates the plot. Really just this line annular wedge right here that generates the plot. We're drawing annular wedges. And then we have this simple while true loop that simply stores new data coordinates for the different parts of the glyph. And you can see it says, current session, store the objects. And sure enough, we see the plot reacting to that and updating in real time. And all the standard tools, resizing, panning, all of those are available. A resize tool. Okay, I don't know why it's not letting me select resize tool. That's interesting. But anyway, all the standard tools there are available. We can reset that as well. So I'm actually running off master, so we might have a few little bugs there, and that's fun. Live demo is made even more fun by running off master. Okay. I also mentioned things like linked panning and linked brushing for interactivity, so here's some examples of that. Here I have shared a range between some plots. So in the first two examples here, I've shared both the X and Y range. So when I pan the first plot, the second one updates its X and Y range, but the third plot only shares that X range. So you can see it only, has linked panning in the X direction. So it's very easy to express that. You can see here I've just passed the range from the first plot into the second one, and it's very easy to spell. Again, zooming does all that as well. Linked brushing, another thing. Again, if you have selections, here I've got a plot that I want to make selections on, so I can pick my box selection tool, and I can select some points. So that's a box zoom tool, sorry. Box select, and I can see that the corresponding points in the data source are updated on the other plot, right? So I can use all kinds of selection tools. Maybe I've got my lasso tool over here, and I can see that work. So again, very easy to spell that. In this case, instead of sharing a range, we simply share this data source. So you can see they have the same data source object passed into them. So it's very easy to spell this kind of linking and sharing with Bokeh. All right, close a few more tabs, make it easier to navigate later. Okay. What else can we show off? Big data, another concern of ours. We want to be able to handle large data sets, so there's a couple of different ways this might be expressed. You might have like large data cubes, and obviously you don't want to ship gigabytes of data into the browser. Maybe you just have a lot of points. If you're doing like a scatter plot and you have 10 million, 100 million points, and you try to plot that, obviously you'll just get sort of a solid mass of color, and you can try to solve that using things like alpha compositing, but we actually have a couple of different features. We have some downsampling. We also have something called abstract rendering, which is a contribution from our academic collaborator. So Bokeh is actually, I should have mentioned, is supported in part by the XData initiative of DARPA. And so we have an academic collaborator, Joseph Cottam, who's been involved with the stencil grammar and ProtoViz. And he's got some really fantastic ideas about how to handle sort of large, when you have this large 100 million data points, what can you do with it to sort of intelligently extract information from it in a visual way. And that's called abstract rendering. And so we're working on porting some of that into Bokeh. But the basic idea is that you can do sort of pre-rasterization. You imagine when you're actually drawing all of these graphical primitives to the screen, you're actually filling in a memory buffer, an array of points, and they get drawn to the screen, but you don't actually have to draw to the screen. You can separate that process, and you can keep statistical information about where these glyphs would be drawn on a synthetic canvas, if you will. And then with this statistical information, you can do a much more intelligent downsampling, or you can do a much more intelligent sort of alpha compositing. You can have, for instance, a non-constant alpha over your data. I like to think of it as sort of high dynamic range, HDR for data, if you're familiar with HDR photography. We can see a couple of examples here of big data sort of as well. not super big data, but some bigger data than you can normally get in the browser. So this is actually, I think, a 4 gig data cube. It's living on a DigitalOcean box somewhere. It's some ocean surface temperature data, and looks a little bit different because we've got an older version of Bokeh that's been running this for a while. But you can see as I zoom in, I get sort of this nice progressive refinement, right? That's fairly, again, like I said, this data is not on my laptop. It's in a box somewhere across the US. And so I can get in, I can zoom in, I can get this nice progressive refinement, even over conference Wi-Fi. It works pretty well. So this is afforded by that Bokeh server. So I mentioned the Bokeh server, is an optional piece of Bokeh, also BSD licensed like the rest of Bokeh. And it's a place where interesting things can happen, right? So we can do things like server-side downsampling of this 4 gig data cube and have it return just enough data to render in the browser. Another example is with this time series downsampling. I think this is 2.1 million points. And so again, I can zoom in and get progressive refinement on the data, and I can have this nice interactivity, even though, again, on the server, there's about 2 million points. Finally, the abstract rendering, I don't have a good demo to show off, but I can point you at the docs for that. There are some early examples of this. It's sort of an early feature. But again, the idea is you can do very intelligent downsampling. So this, I think, was about 100,000 points. And it's sort of been alpha composited in a much more intelligent way to let you see greater areas of detail, sort of high and low, than you would be otherwise be able to. Okay. Another example. And as I mentioned, all of this works in the notebook, right? So you can use, it's really flexible how you can use Bokeh. You can create standalone HTML documents with the data embedded that still have lots of interactive tools. You can use the server that gets you even more kind of interactivity and widgets and the ability to sort of have this back and forth between a running process. You can do this in the notebook or outside the notebook. You can embed them in Flask apps or Django apps. There's all kinds of ways to embed Bokeh plots. And then I mentioned no JavaScript, right? So that's the really important part. So here's some examples, sort of typical prototypical kind of code you would use to generate this, right? In this first case with Texas, what we want to do is to actually show all these counties. So those are really polygons. So we have this patches glyph that we can just sort of vectorize over our data, and it shows all the different patches just sort of fall out of that with the appropriate colors. Again, a histogram here. Here we can see we can draw a bunch of quads and some lines for the cumulative distribution and as well. And this is actually even simpler. So we have a very layered approach for APIs in Bokeh. This is sort of the middle layer API. There's a very low-level object API. I'll talk about it in a second. There's this middle sort of MATLAB, Matplotlib level of API. And then there's a charts API that we're working on that's even higher level. And that's really where you get sort of one-liners for things like histograms, things like time series. You can make them even simpler than this, right? Sort of you pass your data in, and it generates these schematic statistical kind of charts, and so that work is ongoing, but there's some charts there already. Another example, here's just some elements data. This is colored by, I think, colored by their melting point. It's actually a contributor made this chart and donated it to our gallery. We'd love to get more Bokeh charts that people create, be able to add them to our gallery. That'd be really cool. But anyway, this is again fairly straightforward to create from Python, no JavaScript. So that's sort of the main thing. Maybe just a quick few words about the architecture, and then we'll take some questions. So this is sort of what plotting to the browser typically looks like or has looked like in the past, right? You would imagine generating a bunch of code. You actually generate JavaScript programs, right, that draw the charts, and that's what you ship off to the browser, and it's sort of a one-off, one-shot kind of approach, right? So you have some model, and it generates this code, and your server serves it up, and it draws the chart that you want, and that's great. It's done. And there's a lot of examples of that sort of thing happening. Again, you don't have things like data streaming or this nice model. Bokeh.js has a little bit of a different model, right? We tried to make it very decoupled between the browser and whatever's generating the actual models for the plot. So I like to think of it sort of as a dynamic scene graph rendering compiler. And so the reason I say it is because there's actually an object graph that's created in Python, and then that object graph is serialized and sent over to JSON, and then it's reconstituted in the browser as a set of backbone models. And then Bokeh.js, the client library, uses that model to render the scene. So just in case you're curious about the kind of tools we use right now, we use HTML5 Canvas. There's some talk about maybe looking into WebGL Canvas to get even better performance. We use Backbone for our MVC. Most of Bokeh.js is written in CoffeeScript, interesting sort of language that compiles to JavaScript. Uses AMD modules, and it works perfectly well, for instance, in JS Fiddle. So you can go to JS Fiddle and play around with it, and again, we wrote all this JavaScript, so you don't have to write JavaScript. So this is sort of a notional diagram of what the model for Bokeh is we create this object graph. The server, it's a serialized version of that. That gets shipped to the client, and then that same object graph is reproduced inside the browser. And that's a very flexible thing. But the Bokeh server adds even more capability, right? Because now we can connect the object graph that's stored in the server directly to the client, to the browser, and we can use, for instance, a WebSocket connection to have those updates. So again, if you update the object graph in the server, the plot responds automatically and immediately and updates itself as well. So if you push a new data to the plot, you'll get new data in the plot, or if you push new renders, new glyphs, all of those will show up as well. Excuse me. Definitely had a nice time at the happy hour last night. Talking loudly in bars has left my voice with a bit more of a, I don't know, a stern authority than it normally has, I guess, but hopefully that's not too bad. So just a quick look at what this translation actually looks like. So here you might see some code that generates this iris plot. So this is the iris data set with the different kinds of species of irises and colored by their species and sort of what's their, in this case, I guess it's the petal length versus the petal width. And so we could, we can see what that plot looks like actually on our gallery. So if I go to the gallery here, it's just this iris data. And again, so it's fairly straightforward. Zoom in and out and pan all around, so that's good. So yeah, so that's what the Python looks like. What does that actually get turned into? Just in case you're sort of curious, it gets turned into this, right? So this is a lot of stuff that you don't have to worry about. That's the reason I show it to you. This is what we're trying to save people from having to sort of deal with, is to writing this sort of code. But if you do look at it, if you stare around, you can sort of see the structure of it, right? There's a little bit of code that sort of sets up all the models, but all of the data, that object graph dimension, is stored in that all models equals JSON data. That's that big pile of data on the last slide. You can see there's these JSON objects that say that they're things like axes and grids and plots, and there's circle renderers and column data sources, and so the data is actually all embedded now in this particular example. But you could also have references to data sources that live on the server, which is how that streaming and updating plots work. But anyway, so this is sort of the 40,000-foot view with all of that detail pulled out. But we can zoom in a little bit more, and we can see this is, for instance, a prototypical kind of serialization of one of those objects. Here's a column data source. It has these columns X, and it's referenced by this data range, that sort of thing. And the reason I mention all of this is because Python's not the only language that can generate JSON. And this, I think, is actually really exciting as well. So there's one of our contributors, a big Scala guy. So he's actually started Scala bindings for Bokeh. There is Julia guy as well, Samuel Colvin, who's been working on Julia bindings for Bokeh, so native library in Julia that can speak to Bokeh.js. And there's some folks on Twitter who I think are starting to collaborate on an R. I would love to see an R binding for Bokeh as well. But you can imagine anything. I mean, we could write MATLAB bindings for Bokeh or anything like that. So I'd love to see bindings for Bokeh everywhere. Obviously, at Continuum, we're heavily a Python shop, and so that's where we spent most of our time and effort sort of investing in Python bindings. But there's no reason it couldn't be pretty much anything. So anyway, what's next on the roadmap? First, I'll actually mention we should have a release right after Thanksgiving, 0.7 release. A lot of new features there. Some of the stuff I've been showing has been using that new code that will be into that release. A lot of new tools, much better tools, touch support. We also finally have that much better data table that I just showed off there is in the new release. But in the future, we're going to be doing lots of sort of data-driven layouts. So you can imagine wanting to position elements on the plot or the plots themselves, sort of faceting style layout driven by data. And so that's coming. Being able to edit the plot attributes directly on the plot, so you can edit the title or manipulate the properties of the tools right there on the plot. Some of that's already there as well. You can turn on some of the inspectors and turn them off in the plot. SVG output, this is something people ask for. I'm not sure what the time frame for this is. It's something that's important we want to get to. I'm sort of pinning my hopes on Matplotlib's enhancement proposal 25. They're working towards a serialization scheme for Matplotlib, and that would be really fantastic. It would allow Jake Vanderplas's MPLD3 and Plotly and Bokeh to all leverage all of the work that's gone into Matplotlib, for instance, to generate static SVG and PDF and EPS outputs, and also give us better compatibility going the other way. So hopefully that will go forward. I don't know what the time frame for that is. We want to make a nice command line tool. You can imagine something like the GNU plot right in the command line, but you could also imagine tailing a continuous log file to a Bokeh command line tool and simply having an updating plot in the browser automatically. And so that would be kind of cool. And again, improved GIS stuff is big, high priority for us as well. Some other just last few examples here. Again, some data apps, the cross-filter tool I think I showed. This is a product we might actually build on top of Bokeh and Blaze. That's our ultimate goal, is to sort of build interesting things on top of these, but let me show some of these other things first. So lots of calendar. Okay, I'm not sure where I lost that tab, but I can still show a few other things. Oh, one other thing to mention, there are a lot of example notebooks up on NBViewer. So we have a nice NBViewer site. It's on the main NBViewer page. You can go there. You can find a ton of notebooks, as well as the tutorial examples. So the tutorial notebooks have been taken from their original .py file format, modified by Christine Doig into these fantastic notebooks that have like hidden solutions directly in line in the notebook. And so I encourage you guys to check those out. But there's also just example notebooks, and it's a really fantastic resource. So I encourage you guys to look at that. This is sort of an example of that data portal. Idea behind this data portal, again, this might be an actual product that we make, is that we want to be able to have a catalog of our data that we can interact with Blaze, and so we can interact with a lot of different kinds of data because we're using Blaze. We can farm out compute to a lot of different compute front ends because we're using Blaze. But then we want to be able to publish and create dashboards, bokeh plots and charts from that. So this is the idea is very easy, being able to create these plots, but also to publish them as dashboards and lay them out in the way that we want. So that's some of the things that are coming along. Last but not least, so how to contribute. Again, everything here is BSD licensed. Bokeh, the JavaScript library, the Python, the server, is all BSD licensed. We definitely would love everyone to use it and give us feedback. That's the primary way that we get bug reports and feature requests and move things forward. Definitely feel free to, though, engage us if you have custom requirements. We're always happy to sort of work on all kinds of things with people, not just for integrating our code, but we can bring hopefully analytical and visualization expertise as well if you have any need for that. But all of that work that people come and engage us with certainly helps our open source efforts and move the open source tools forward. So it's up there on Bokeh. If you go to the Bokeh organization on GitHub, you'll see a lot of different projects now. It's actually pretty exciting. You can see the standard Bokeh library, but you can also see, again, Bokeh Scala, Bokeh notebooks for the NBViewer notebooks. Hopefully Bokeh.R will make an appearance there as well. So anyway, I think I'm just about out of time, but try to take a few questions. Any questions? Yeah. That's a very early project, and it's also that's probably going to be a commercial product built on top of Bokeh. Yeah. Do you have a question up here?
Yeah. So about the next version coming out, one of the things I haven't been able to figure out how to do, maybe it's there, is get individual values for things in line plots or like scatter plots.
Okay.
Is that coming out? Or?
So what do you mean by so the question is about how? Yeah. So hover is implemented for almost all the glyphs. We don't have it yet for hit testing for lines, so that's one reason you might not have found it on lines. But it works for just about every other glyph, circles and scatter type glyphs and patches. You can definitely get both the screen coordinates, the data space coordinates, as well as the index into the column data source of which glyph you're actually hovering over. So if you want to come find me later, we can sort of talk about specifics. But yeah, all of that information is available. Other questions? Yeah.
So I think there's been a lot of interest in how you are showing replacements in Python. How much do you have to put in to get those widgets and everything?
Yeah, that's an ongoing process making that better. This is an area where feedback from users is really, really very valuable. So I would say it used to be fairly difficult, and now it's a little bit better, and we want to keep smoothing those rough edges over. Basically, there's some layout classes. See if I can find maybe an example here in GitHub and show, for instance, that spectrogram example. So again, the spectrogram example was sort of a nice example of sort of hybrid development where most of the heavy lifting was done in Python, but we had a little bit of JavaScript that actually updated the data because we can grab that plot from JavaScript. And so that's kind of, because people ask for that, and that's pretty cool. But if I find, embed spectrogram, there we go. If I look at spectrogram.py, here at the bottom you can see I create this layout. Most of the code in here is actually the FFT and the PyAudio sampling. But here you can see I create those 4 plots, right? I create an image RGBA for that waterfall plot. I create 2 line plots for the power spectrum and for the actual signal, and then I create this annular wedge chart for that sort of integrated, binned radial graphic equalizer plot. So there's these 4 plots, here and here and here and here, and I put them in a VBox, and I put the the VBox in another VBox, and I pass that layout as what I actually return, and then that's what I call show on. And so it's getting better, right? And we'd love to make it even more better, but that really, again, feedback from users is invaluable for that. Especially new users, they have the best perspective on why is this harder than it should be, or why can't I find the information, and so that new user sort of perspective is incredibly valuable to me. Unfortunately, it goes away the longer you use the tool. So if you guys do try out Bokeh, please give us feedback and let us know what we can make better and what else we can improve. But yeah, other questions? I think we have room for maybe one more question. Yeah. Oh.
Hi. Really nice talk. This was wonderful work.
Oh, thank you. Oh yeah, great question. So right now you can do some kinds of integration with the IPython widgets. I mean, you can use it to update things in Notebook, so you can use it to update a plot. There's not a very tight integration yet. We want to make that a much tighter integration. So we do have our own widget toolkit. I mean, and the reason for that is because we need to work out. I mean, the widgets in the IPython notebook basically assume we're running IPython kernel, and we need to be able to work in dashboards and places where there isn't an IPython kernel, right, in standalone documents even. So that's why we have to have our own sort of widget toolkit, but we do want to work very well with the IPython widgets as well. And so that's also on our roadmap, is to sort of make that integration even tighter than it is. And it's certainly doable. We just haven't. We have an infinite to-do list, of course. So again, please come help. Okay, great. All right, well, I think that's time. So thank you guys for coming to my talk.